Okay, I'm just going to be giving a talk sort of on some of the hobby stuff I do and some of the thoughts I've got about sort of where music recording and that and sort of studio stuff is going. Basically, I've called it linking outside the box because, as I'll explain, it's what's kind of happened over the years with digital audio workstation stuff is it's all moved into the PC, and this is kind of a process of trying to get some of the control of it back out again, because a mouse and keyboard are not really the ideal interfaces. So basically we're going to have a quick history lesson of how sort of music used to be done and how it's now being done, and then have a look at some of the ways of connecting things up and the various sort of protocols and things we can use. And I'll look at some of the hardware sort of solutions I've been building and playing with, and then some of the software ideas I've got, and we'll have a look at some of the future directions of where maybe things are going. So basically, in a traditional sort of analog music production, you've really got three broad steps. They're obviously not all followed exactly like that, and there is some overlay between them depending on how live it is, or the mixing and mastering sometimes crosses. But generally, it's very much a sort of capture process. In the old days, it was onto multi-track tape. And then it's your sort of mix down where you bring in those various tracks, you position them in the stereo field, you kind of sort out any phase corrections when you're doing that. And then the final mastering generally was a very formal step because you were mastering for a vinyl format or cassette formats where you had to do a whole lot of, sort of prefixes. In the sort of vinyl format, you would force all the bass into the center because records physically couldn't handle a stereo bass signal. On the tape, you'd obviously add Dolby. So it was a very clearly defined sort of set of steps. And then over the years, as you've digitized more and more of it, we sort of, well, sorry, there's an example of what I was going to show. So it's your capture process. There is some sort of steps that you're going through where you're modifying the signal at capture. But what I sort of really wanted to display here is that at every step of the process, you've got a lot of buttons to control what you're doing. And every button has its own function. When it's set up, you can kind of leave it, and it just works the next time you come around. Of course, it doesn't translate very well to a week later where somebody might have moved it. You can't save the settings, short of taking a photograph or putting scribble tape all over it and marking it. So it's great, you don't lose the settings immediately between sessions, but it doesn't last very long either. So that's kind of the process, the mixing process. Again, there's a lot of buttons to control everything. It's a very physical sort of human interface, been designed over a long time to do exactly what it's meant to do, and then again in the final mastering stage. Nowadays, what you're seeing in a digital workstation is a lot more of this is done all in the box. There's a lot of overlay, a lot more overlay. So generally when you're doing the recording, you will still keep all the tracks separate, but in the same solution that you're doing the recording, you will start doing some of the mixing because you're using all the tools there. What I've done here is that rather than say guitars, I'm sort of proving that, with a lot of the synthesizers and sequencer type stuff, a lot of the music creation is also happening inside the box now. So there is still an analog component, microphones, guitars and things, but even a lot of that is now sort of moving inside and is becoming done effectively with a mouse and keyboard. And again, so the whole process, you're still doing all the same things, but a lot of the outboard effects now are just plug-in devices, VSTs or LV2s and stuff. But basically it's still the same process, but it's all happening inside that. And your only way in traditionally is through a keyboard and a mouse. Can get pretty clumsy because also your screen space, unless you've got a multi sort of 6-screen device, you end up with windows on top of each other, which is not really ideal in music because you want to be watching all the levels. You want to move 3 or 4 faders at the same time. You can't really do that with a mouse, so it's not an ideal interface. So some of the gains you get when you move to digital, obviously most of your path is lossless. You're not getting the sort of delay. Every time you go tape to tape to tape, you're adding a little bit of noise in there. Other than the effects you're adding and stuff, you're not really losing anything. Your recall now between takes and stuff is a lot better. So when you bring your project up, every setting you had is already there exactly as you left it. You don't need to write it down or have it stored anywhere. A lot more portable, of course. You're not moving a studio with you wherever you go. And infinitely editable, whereas in the tape days that was, when you start splicing tape, it really is a one-off thing. You can't keep doing it. But you've lost that interface. You really do give up quite a lot for that. So there's an example of, a typical mixer desk. Everything is designed to kind of fit human hands, and it was never designed just to be flashy or to look nice. It's designed to be practical, which is the big thing that we've given up. So how are we going to get stuff back into our computer and start using some external devices? On a traditional computer, really, for external sort of control devices, USB and network are the most common ways in. FireWire is great for audio. It does support MIDI, but it's a pretty expensive solution if you just want to do MIDI, because it's such a low signal rate. You don't need the whole setup for FireWire. And network. Obviously, most computers have got a network now. It's pretty fast. It's pretty versatile. And the two equivalent technologies that kind of map to those is MIDI. MIDI is traditionally a sort of serial port type-based protocol, but most MIDI adapters now are USB adapters. And the MIDI spec does actually have a proper USB device class in it. And then Open Sound Control, pretty much Ethernet-based UDP packets over the network, can work over wireless, can do pretty much anything. We're not really trying to do proper music playback, it's more control. So we're not worried about sort of 10 millisecond kind of latencies. It can be a little bit slower. So MIDI, designed really to capture and play back musical instrument notes and pedals and that kind of thing. Not originally designed purely as a control interface. Very, very compact. Everything is sort of bit level. So a note off signal is 3 bytes, and you have to actually measure the first 4 bits indicate the command itself. The next 4 is the channel. So it's very, very low level. Ideally designed, if you're building a little microcontroller type circuit, really good, because it's also designed so that you get as much information up front rather than later on. So you can make your kind of coding decisions very early on without having to hold a big buffer of information. Where when you're designing on a microcontroller with sort of 8K of RAM, those things become quite important. Wide industry support, virtually all synthesizers, outboard devices all have some form of MIDI control built into them. Traditionally, it's 31-2500 board. It looks, from a hardware point of view, it looks pretty much like a serial port. And as I said earlier on, there is also a USB standard. Some of the limitations are it's only got 60 channels per sort of message set, or per device. That generally is ignored by most devices. They listen on all of them anyway, because trying to set each device to its own channel, particularly in the software world, people thought it was just too much of a pain, because you start with one device and you're only ever going to use one, so I'll just listen on everything and make it easier. So the 16 channels don't really even exist as an expansion option. It's generally you've only got one kind of thing on each one. The actual size of the data itself is generally a 7-bit, so the data information it's sending. So if you're moving like a fader, you're only going to get a 7-bit signal, which is from 0 to 127 as a value range, which is fairly grainy. Particularly if you're moving it fast, you tend to get that zipper kind of effect. It's, the human ear can notice it. Each channel allows you to have one 14-bit signal, which is your pitch control. But again, you've only got one per channel, so you end up really trying to hack to get more than one of those in. So if you're building a multi-fader device, you very quickly run out of options, short of making it look like a multi-USB device. Open Sound Control, as I said, it's TCP/IP based. It uses a more sort of human-readable URL type notation. The messages are specific to the application, so it allows the application to expose itself in a much clearer way. In the case of MIDI, it's really you've got note on, note off, continuous controller type messages. They're very specific to what a musical instrument would have been creating. And when we move to using it to actually control applications, we kind of hack. So some applications will say, well, I'm going to use note on, note off to control a button, and I'm going to use continuous controllers for my volume type settings. Other people do things other ways. There's no standard. So at least with Open Sound Control, there's a little bit of sanity in the world again, in that the things are human readable. An application can say, these are my sort of standard set of interfaces, and it's not going to clash with anybody else's, hopefully. If you're writing at the microcontroller level, of course, this becomes a lot harder because you are doing a lot more work. You've pretty much got to store 20 bytes there before you can even make a decision about what you're doing. You've got to have a whole TCP/IP stack sitting on your chip. So it's really, for that small microcontroller stuff, is not as great from a programming point of view. Port mapping is still an issue because everybody picks as I'm on this port, I'm on this port. From an automated point of view, where you want to have a whole bunch of outboard kit automatically connect and know what it's talking to, there's still a lot of mapping and kind of hacking around that you've got to do. So, some of the things I've been doing is I've been trying to build some hardware devices that use MIDI. As I said, MIDI is fairly simple. It uses a serial protocol and or a USB class interface. That's a basic MIDI idea. I'm jumping in a little bit technical here just to sort of give you a quick overview. It uses DIN plugs. It's always got an optocoupler on it. The idea is that there's no signals, hum or any kind of static can get carried through into any other equipment. That's pretty much mandated by the original standard. So everything goes through an optocoupler. And that's really it. And then it's just like a serial port coming out of there. Pretty simple, really. This is one of the sort of projects I built. I might try and plug it in if we have time. It's basically, that's what it looks like. Simple circuit board. It's pretty big and looks complicated, but it's not really. It just had to fit into there. Again, 2 DIN plugs at the top and the optocoupler, CPU, and a couple of other devices to do it. So really pretty simple. And there it is. That's what it looks like. So this is just a 4-channel with a master. Just analog faders and some rotary controllers. Rotary controllers are a bit of a funny again because one of the things that you get with an external device is that you get it's very immediately visual. So I know that that fader's halfway up, that one's slightly less, and you can kind of get a very quick overview of the state of all your tracks by looking at them. A rotary controller was kind of a solution to one of the problems with the faders. Unless your fader's motorized, when you start a session and you load from your software, it already knows where it was last time. But if you've zeroed all of these subsequently, they're not going to get put back to where the software thinks so. So you've got this mismatch now between what your software thinks and what your hardware thinks. One of the first solutions was to use rotary controllers. They just go round and round and round. They don't have a state. So, and then generally on a more visual sort of proper device, you'd actually have a little circle of LEDs around it. And so the software can actually say that's where the thing is turned to rather than trying to manually do it with a motor. With faders, you can't really do that. You could use motorized faders. This one is not motorized, but it's very much similar to do. Just a quick jump in. I wanted to talk about Securemorphism. It's a big buzzword now in the Mac world and everything, and that you shouldn't be basically trying to copy. So what I'm doing here is effectively I'm copying the old analog interface into my new digital world. And whenever you do that, you've got to kind of challenge yourself at, are we being skeuomorphic? Are we just copying form over function? And are we not really gaining anything? So my view here is that what we're actually trying to do is we're trying to get the function back rather than just the form. So we're not copying a mixer because it looks like a mixer. We're copying it because it's the fingers actually fit there correctly, and that's the intention. So I would say we're not really being skeuomorphic. The temptation when we do it, sometimes some of these, the layout and stuff will tend to copy a mixer or an existing hardware interface, analog interface more. As we sort of go through the first iteration of design, people start realizing that certain things are actually not adding any functionality or laid out incorrectly in the new digital world. and the changes will come. And you'll see in some of the newer MIDI type devices that people are building, they've almost abandoned this kind of layout and are going into sort of more button matrices and that sort of thing. So yeah, so I don't think we are being skeuomorphic here, and we really are trying to capture the function. USB MIDI. Generally, from a microcontroller version, writing a USB device is pretty complex. You need specialized chips. There's a lot of timing issues. But at the USB 1 level spec, the system is slow enough that you can write it in software. So there's a company have written an open source product called VUSB, which is a set of firmware libraries for Atmel chips. In this case, I'm using the ATtiny. And basically, everything becomes software driven. You've got 3 GPIO pins on your microcontroller. That's all you need to dedicate to it. And at a very low level, this thing is running at, I think you can run it at about 6 megahertz. So it's low power, low speed, and you can run a USB 1 type device off it and do everything in software. And even the 5 volt, you just use a couple of diodes to get it down to 3. So really basic, and then everything's a software solution from there on. That's a device I did that uses that. I was hoping to point you to the back and show you, but I don't think we're actually using them. It's one of the things we're doing with our video recording is we have a concept of a tally light, and that's generally on each camera you have a little red light on top of it, and as people switch cameras, the light will light up on that one so the presenter knows where to face and which camera to look at. These are the ones we designed for the Perth Linux user group. The traditional one we've been using with DBSwitch is a serial-based solution, and of course there's no serial ports now on most devices, particularly on laptops. So it's a simple plug-and-play USB device. It looks like a MIDI device, and it just takes note on, note off to turn the lights on. So middle C will turn the big red lights on, and then it's D, E, F. Everything from a Linux point of view, as long as you've got ELSA loaded and you've got a MIDI, you can script anything on it. There's no additional software needed. So again, pretty simple circuit, tiny little board. I think about $20 to make each one. Really basic. And yeah, there's an example of it with one of our cameras. The 3 at the back we're not really using at the moment because DBSwitch doesn't support signaling on them. It just tells us main tally. But the intention was to extend that and use those for indicating other things like your camera's out of focus, or we're about to switch over to you, make sure your camera's steady, that kind of thing. And there's another one I'm working at. Not a lot I can show you there. It's basically it's the same thing again. It's an ATtiny. It's a bunch of TTL devices. It's to switch, and that's going to do timecode, MIDI display, and it's going to be extended with a bunch of buttons so you can stop. You can set markers in your track. So the idea is to have a rack mount with a nice big display, and you can use a sort of the MMC controls in MIDI, which is your play, record, stop button type of functionality, and have 10 markers within your track so you can do sort of, jumping between when you're doing the recording stuff. So bringing it, again, back out, giving you a little bit of a visual surface to work on. Open software control. Pretty much most of the stuff around this is involved in software designs. Obviously, once if you want to move it to hardware, you just got to get a TCP/IP stack up. But most of the work really happens in software, and it's dead easy software, really. There's a very simple Python controller. This is designed for DBSwitch. So it's not exactly all the code. There's a couple of sections left out, which are just GTK type setups. But really, the 5 lines in green are all it is to get going. And you're running open sound control. Yeah, and that'll just allow on DBSwitch you can switch the different cameras, ports that you're using, because DBSwitch supports open sound control as a control protocol, as does ARDA and a lot of other things. This is another example of an OSC tool. Again, for DBSwitch, I'll actually get up DBSwitch and I can demonstrate that using both of them. This is an Android application that you can get. It allows you to define your own layouts with a little Java application that you can run on your PC. It does run on Linux. you just design a layout, you assign OSC controls to it, and pretty much you can use your phone to control anything. So in this case, it's a phone controlling DBSwitch. Yeah, and then just looking sort of towards the future, where we're kind of going with it. I think a lot more use of tablets are going to be coming out. They kind of mix the versatility of the software, of the flexible being able to change the interface, but you're still kind of getting back to having a proper human level interface that's more appropriate to using rather than a mouse and keyboard. Phones have a lot of devices on them, accelerometers and stuff. I think a lot more use of those as gesture-based applications. This Touch OSC application actually allows you to assign some of the accelerator commands and stuff to it. So you can use your X acceleration and stuff to control things. So you can get pretty flexible with that. Slate Raven MTX is a new, relatively new mixing board. This has come out. It's a big 48-inch screen which is completely touch sensitive, and they've moved all the controls onto that. That seems to be getting pretty good reviews, and it's kind of another example. Things like the Monome project, which is basically it's just a matrix of buttons. People use it more for live sort of playing rather than a recording type thing. So there's a lot of new ideas coming out and a lot of options that we'll be seeing in the future. So yeah, I'm just going to try and get these in and just give you a quick show of how these work. Let's see if my screen will let me get the command line up. So basically with this one, it's just a USB device. As I said, I showed you it's a pretty simple circuit. Of course, I'm not going to see it this time, is it? Oh, sorry. Just from a MIDI perspective. So the Tally LED, seeing the device. My desktop, I've got a little. Oh, I'm already in there. Sorry. And then that's basically just cycling through it. As you can see, so each light coming on and going off. And literally, just to show you what it's doing, is really just sending a MIDI commands with a MIDI note on command. So NO3E00 is send a note on with 0 velocity, which means turn the light off, and send the note on with 7F, which is full velocity, turn it on. So pretty straightforward, really. That one there. And then, again, as I was saying, with traditional MIDI devices, you would generally nowadays you would use something like this, which is just a MIDI to USB device. So it's doing effectively what my earlier circuit was doing, but it gives you the proper dual DIN plugs coming out of it. So that's normal traditional MIDI. I'm just going to plug this in and see if I can get it working. This is really pushing my luck. Yep, so that's pretty much working. I'll get Ida up now and just show it to you. Sorry, I've just got to quickly do that. In and out the wrong way around. Okay, so yeah. Okay, so you basically see there, but that's the typical issue you have with these, as you can see. So if this is set sort of, it's not really flowing very well, is it? I don't know what's going on here. I must have got bashed. It's not sending it. Sorry. But yeah, basically you can see you can enable your recording. So it's just like any normal one, and it's pretty easily supported by ARDA. And again, you can use Open Sound to control it as well. Yeah, probably a little bit early, but I think I'm about done. Yeah.
Why is it called a Tallylife?
That's a very good question. It's an industry term.
Okay.
Euan, are there any tablet interfaces which are tactile?
Not that I'm aware of at the moment. I know they are playing quite a lot with that sort of haptic feedback on touch surfaces. By using specific vibrations at the right speeds, you can actually create all kinds of texture fields on the surface. So
Actually,
there's a lot of research going on there.
Yeah, I was reading about, I can't remember where it was now, but yeah, I think there is a product which, it's either a product that's about to be released or has just been released, which that does actually provide tactile feedback, and it works on a vibration model, as you said. I can't remember the details of it now, but I'm fairly, yeah, there's either something about to be released or has been released that does exactly that. I mean, that has implications for blind people and a whole bunch of other accessibility things just beyond music, but yeah, it's a very interesting area.
There's a slightly different way to do it as well. For their tape machines to do mixing consoles. And what they actually did was decent sized LCD screen, and in front of it, transparent rows of controls. So you've got knobs and such in front of the screen. So it's not, and buttons as well if I recall right. So it's not fully, it's an interesting way to mix it.
There's a lot of fun.
Not fully virtualized, it's almost physical. And the idea there is that the function of the surface can change depending on what they put on the screen underneath it. And so it can, like you've got your fixed controls, but what they put underneath that dictates what those controls do and give you your visual prompts, as it were.
And
slide across it will actually give you the sensation.
I don't know if you ever saw any of the Microsoft Surface videos as well, but they have that nice capability of a camera that's watching the, they've got a half silvered screen and it can see what's placed on the table and differentiate stuff that's above the table versus stuff that's contacting the table. And so they have physical controls that are a plastic unit with a fiducial printed on the bottom. When you put it on the screen, it knows where that is, and as you turn it, it can see rotations. And
The thing, we can kind of get those interfaces will work if you've got a whole system designed to work with it.
Yeah.
But once you get, the chances of that actually happening, being true once you get relatively into audio is very small, because inevitably you have a huge pile of third-party plugins written by someone or other.
Yeah.
All work together. Very few of which even support OSC, basically, like more complicated stuff like specialist control service protocols or something, and then to add on top of that, and we want you also support this particular haptic interface. Your chances of
One of the problems even with OSC is trying to get just to get through the door into your plugins. So, from your audio workstation, you can control every aspect of that, but to actually pass that on to any plugins that you've loaded into there. Some of them, like ARDA, do actually provide some of them, but it then tends to vary depending on which one.
And some, there are a few commercial plugins that get support.
Yeah.
That's pretty rare. But those do a good job of it.
Yeah, we're not there yet.
One of the things that, yes, you touched on the idea that tablets are sort of increasingly being used as control surfaces, and there's a lot of professional mixing desks from the likes of Tardis and Co, and even lighting consoles, where they don't use OSC, and they provide a single application for a particular make of tablet. And if you happen to not run that tablet, then you're out of luck. What is starting to happen a little bit now is that some hardware manufacturers are using OSC internally, which at least gives the community an opportunity to write a skin for other devices. And also, of course, gives you the option of scripting stuff and all that sort of thing as well that you just don't have with the pure graphical control. And so the relevance of OSC will, for hardware devices, may actually rise over the next couple of years as more and more manufacturers realise that, yeah, actually, if we go with OSC, then it's actually more flexible, and we're not locking ourselves in the single tablet variants and this sort of thing. So there's going to be a bit of a growth area in that.
OSC really seems to be one of those things where we had the right standard technology solution there for ages, and convincing people to actually take it up. There seems to just be this giant struggle. It's been close to a decade.
I think
OSC will take over any time now. Oh, it's not.
Yeah, I think it's in many respects it's the same. It's probably the same open source problem that we've had all along, but in a slightly different guise.
Yeah.
For a long, long time, and to a certain extent it still exists, the whole video card driver problem, which has slowly become better over the last couple of years. And before that was the network card problem that slowly got better as the manufacturers woke up. And in many respects, I think we're starting to see the same sort of thing happening with the more advanced hardware devices that are now coming out. That we've started out that people are writing proprietary protocols to control their own proprietary devices. And of course, that means that if you don't happen to run the one tablet that they are interested in supporting, you're basically out in the cold. Whereas, slowly a few manufacturers are now starting to wake up and say, hey, if we use OSC, then it doesn't really impact our ability to write our own control application, but it means that others can also do it, and they might be able to do cool things with it that we never thought of. So, again, it's probably the perennial case of having to educate manufacturers of the fact that, yeah, it is actually worth your while putting OSC in these devices, especially the Ethernet connected ones. Because, as you said, whilst, putting OSC on a small MCU is problematic, these devices, at least the ones I'm talking about, do not have a simple MCU on them anymore.
Oh yeah,
They've got plenty of firepower, and putting OSC in them really is incredibly trivial. Most of these are Ethernet connected already, so they've already got the stack in them, and it becomes basically a no-brainer. So that's, I think, what we've got to sort of hope for going forward, and maybe even start campaigning about, because it is actually starting to get ridiculous that you can have a perfectly functional tablet, but not be able to control an iLife, because the iLife application doesn't run Android.
Great. Well, thanks very much.
I've got a question.
Yeah.
What about MIDI sync, like for devices like drum machines?
Syncing with the timecode?
Yeah.
Yeah. Yeah, the timecode's pretty simple as long as any one device is providing that.
Can I rephrase that question?
Yeah.
Are there any kind of like open source software for the MIDI synchronous, like as a plugin, like to use
I
as
don't
a...
use them at syncing, like synchronizing that device.
Yeah, that's what I'm talking about, synchronizing
Like
like,
MIDI timecode sync up.
but also like over a network, like on the internet.
Oh, okay. I'm not aware that. I think the internet's still too laggy, really. There is some.
Because there's a proprietary...
I've seen some software for doing
that does that.
network-based sort of collaboration, but I think it's still pretty difficult.
I don't know much about it, but NetJack may or may not have MIDI in it. I don't know. I know that NetJack allows you to synchronize audio streams across networks. What I can't recall is whether they are also capable of doing MIDI transport. But yeah, I know that NetJack deals with the audio side of it.
Yeah, I think Jack does its own synchronizing code that doesn't use MIDI timecode.
No, it doesn't. No, it doesn't use MIDI timecode, although I think you can transport.
Yes.
But it doesn't actually, yeah, Jack has its own time management and clocking system. And it may be that NetJack can do MIDI, I'm not sure. I haven't used NetJack extensively myself, so I don't know. But I know that they've got the audio side dealt with. And if they've got the audio, it would be in many respects surprising if they can do MIDI. But that would be one avenue to look at.
Yeah.
From MIDI over Ethernet is, I mean, there's definitely a net MIDI protocol, and that works in Linux. I played with that.
The next MIDI.
Yeah. That's pretty straightforward. And the MIDI associations themselves are looking at HD MIDI, which is their sort of next revolution.
16-bit controls, I think.
Yeah, finally.
Finally, yeah.
Network and Bluetooth and everything will be included in that.
I guess the other thing, I mean, again, it's probably important to note too that with MIDI synchronization is the fact that the problem of doing it locally is totally different to doing it remotely as well. If you're doing it locally, the delays are irrelevant. But if you are doing it across multiple sites, then suddenly there becomes an issue where you've got to have network lag and transport delays, and it starts to get a bit of a mess, which is the sort of thing that makes NetJack complex. But I think they've sort of solved most of those problems for you. All right, well, thank you.
Great.